What about arc welding? So, is the category of fusion welding? Yes, arc welding is a fusion welding process. Yes, arc welding AW is a fusion welding process in which coalescence of the metals is achieved. With coalescence of the metals is achieved by the heat from electrical arc between electrode and the work. The same basic process is used in arc cutting. A generic AW process shown in the picture. An electric arc is discharge of electric currents across a gap in the circuit. It is sustained by the presence of thermally ionized column of gas, though through which current flow. The initial arc in AW process, the electrode is brought into a contact with the work and then quickly separate from it by a short distance. The electric energy from the arc thus produce temperatures of 5,500 degrees Celsius or higher. So you can find a video on the arc welding. So this consists of the electrode holder, the electrode cables, and welding machine, and electrode or consumable or non-consumable, and direction of travel, and filler metal, and the arc, and the work or molten weld metal, and we also have to clamp with the work table, and this is also called the work cable. So with the technology of arc welding, before describing individual process, is instructional to examine some of the general techniques issues to be applied to this process. Electrode used in AW process are classified as consumable or non-consumable. Consumable electrodes provide the source of the filler metals in arc welding. These electrodes are available in true principle form and wire welding rods are usually typical 225 to 450, which also need less diameter. Diameters is less than 9.5 millimeter. The problem with the consumable welding rods, at least in production welding operations, that is they must shine periodically, reduce arc time of the welder. Consumable weld wires have the advantage that it can be continuously feed into the weld pool from the spools containing long length of wire, thus avoiding the frequent interruptions while arcing when using welding sticks. In both rods and wire forms, the electrode is consumed by arc during the welding process and added to weld joints as filler metals. Non-consumable electrodes are made of tungsten or carbon valley, which resist melting by the arc. Despite its name, a non-consumable electrode is gradually depleted during the welding process. Vaporization is the principal mechanism, analogous to the gradual welding of cutting tools in machining operations. For the process, the utilizations that utilize non-consumable electrodes, any filament electrodes used in the operation must be supplied means of the separate wire which feeds into the wheel pool. And arc shielding. At the high temperature in arc welding, the metals being joined are very chemically reactive to oxygen, nitrogens, and hydrogens in the air. Mechanism property of the weld joint can be seriously degraded by these reactions. This has some means to the joint in the arc from the surrounding air is provided in the nearly all AW processes. Arc welding is arc shielding is accomplished by covering the electrode tip, arcs, and the molten weld pool with blanket of full or flake or board in which inherent exposure of the weld metal to air. Common shielding gas include argon and helium, both of which are inert in the welding of ferrous metal with certain AW process. Oxygen and carbon dioxide are used, usually in combination with Ar and He, to produce oxidization atmosphere to control weld shape. A flake is a substance used to prevent the formation of oxidations and unwanted contaminated, or to dissolve them to facilitate removal. During the welding, the flake melt and become liquid slag. With the operation and protection of the metal weld motion, the slag harden upon cooling and must be removed later by shipping or bursting flake. It's usually formulated to serve several additional functions. Provide a protective atmosphere for the welding, stabilize arc, and welding spattering. The method of flux applications differ for each process. Delivery techniques include pouring granular flux onto the welding operations using stick electrode coated with flux material in which the coats melt during the weld to cover the operations, and using tubular electrode. Tubular electrode in which the flux is contained in the core and released as the electrode is consumed. These techniques are discussed further in our descriptions of individual process. And power source in arc welding. Both direct currents and alternating currents, DC or AC, are used in arc welding. AC machines are less expensive to purchase and operate, but are really good heuristics for welding ferrous metals. DC equipment can be used as all metals with good results and generally known to be better at arc control. In arc welding process, power to drive the operation is the product of the current I passing through the arc and the voltage E across it. The power is converted to heat, but not all the heat is transferred to the surface of the work. Convection, conduction, radiation, and spatters account for losses that reduce the amount of usage. Heat. The effect of the loss is expressed by the heat transfer factors. Some repetition values given. Heat transfer is generally greater than the process, and also use the heat consumed melting electrode is subsequently transferred to the work to as a molten metal. The process with the lowest F1 is the gas tungsten arc welding, which uses non-consumable electrode melting factor for to reduce available heat for welding. The resulting power balance arc welding is defined. So this is about the detail of power and shield metal welding, and also power in arc welding. So it's about the process of consumable electrode. So and they need a lot of gas metal welding and a lot of detail on those welding. So let's focus on non-consumable electrode. So this process uses a non-consumable tungsten electrodes as inert gas for shielding. The term TIG, this is the TIG welding. Yes, TIG welding is tungsten insert inert gas welding. It's often applied this process in Europe. And the BUIG welding is the chemical symbol for tungsten in the bill for wolfram. The GTA build process can be implemented with or without filler metal. So you see later, the filler metal is used to add the weld pool from separated rod and wire, being melted at the heat and the arc transfer across the arc as the consumable electrode aid the build process. The tungsten is good electrode material due to high metal point. Typical shielding gases include argon, helium, and all mix of these gas elements. GTAW is applicable to nearly all metals in a wide range of stock thicknesses. It can also be used for joining various combinations of dissimilar metals. In most common applications are for aluminum, stainless steel, cast iron, bone irons, leads, and all coarse tungsten are difficult to weld by GTAW in steel welding. Application GTAW is generally slower and more costly than the consumable electrode AW process, except within the thin section are involved and very high quality welds are required. When thin sheet are TIG welded to close tolerance, filler metals is usually not added. The process can be performed manually or by machine and automate metals for all joint type. Advantage of this would search for high quality weld, no weld sparkle because the filler metal is transferred across the arc, and little or no post weld cleaning because no flux is used. And also another thing is a plasma. We can use a lot of techniques to do arc welding, like also carbon arc welding, stud welding, and then would be the resistant welding. So we skip it to the resistant welding. RW is a group of fusion welding process that use a combination of heat and pressure compressed coalescing the heat being generated by electric resistance to current flow at the junctions to be welded. The principal components in resistant welding are shown in the picture. For resistance spot weld operation, the most widely used process in the group. The components include work part to be welded, two opposing So we will focus another thing, as I said, the resistance spot welding. Okay, the resistant welding process. Resistant welding process of most commercial important are spot, seam, and projection welding. These processes are shown in videos on Google. You can find it. Resistance spot welding. Resistance spot welding is by far the predominant process in this group. It is widely used in mass productions of automobiles, appliances, metals, furniture, and other products made of sheet metals. If one considers that typical car body has approximately 10,000 individual spot welds, and that the annual productions of automobiles throughout the world is measured in 10 in tons of millions of units. Yes, in tens of millions of units. The economics importance of resistance spot welding can be appreciated. So we can call it RSW for resistance spot welding. This is the RW process, in which fusion of the fairing surface of a lap joint is achieved at one location by opposing electrodes. This process is used to join sheet metal parts of thickness of 3 millimeters or less using a series spot weld. In situations where an airtight assembly is not required, the size and the shape of the weld spot is determined by electrode tip. The main common electrode shaft being rounded, but hexagonal, hexagonal square, and other shapes are also used. The resulting weld nugget typically 5 to 10 millimeters in diameters, with heat affected zone extended slightly beyond the nugget into the base metals. If the weld is made properly, its strength will be comparable to that of the surrounding metal. The steps in the spot welding cycle are shown in the graph. Yes, in the graph. We can find it. The recently they are electroded and apply forces some molten metal and become weld nugget, and apply force and apply current in spot welding. So by far, material used for RSW electrode consists of two main groups: copper-based alloy and refractory metal compositions such as copper and tungsten combinations. The second group is known for superior wear resistance. As in the most manufacturing processes, the tooling in spot welding gradually wear out as is at use. Whenever practical, the electrodes are designed with internal passage way of water cooling. Because it's widespread industrial use, variation machine and methods are available to perform spot welding operations. The equipment includes rocker arms and press type spot welding machines and portable spot welding gun. Rocker arm spot welder, as shown in the pictures, have a stationary lower electrode and a movable upper electrode that is mounted rocker arms, hence the name. Where movement controlled by a foot pedal operated by the worker. The modern machine can be programmed to control force and current during the weld cycle. And the press type spot welder are intended to for lacquer work. The upper electrode have been a straight line. So we talk about the press type spot welders are intended for lacquer works, and the upper electrode has been straight line motion providing a vertical press that is pneumatically or hydraulically powered. The press action permits the larger force to be applied, and the control usually permits programming for complex weld cycles. And the periods of two machine types are both stationary spot welders, in which the work is brought to the machines. For large and heavy work is difficult to move and orient the work to stationary machines. For these cases, portable spot welding guns are available in various sizes and configurations. And this device consists of two optionings electrode contain in a printer's mechanisms. Each unit is lightweight, so that it can be held and manipulated by the human worker or an industrial robot. The gun is connected to its own power and control source by means of flexible electrical cables and air hoses. Water cooling for the electrodes, if needed, can also be provided through a water hose. Portable spot welding guns are widely used in automobile final assembly plants to spot weld car. And some of these guns operate by the people, but industrial robots have become a preferred technology.